Okay, the next example still be in the same cases that the value of the eigenvalue is a repeated root. Okay, the example asking you, the problem statement asking you to find the solution of this linear system. Okay. So the way that we do it is that started with assumption with y1 is equal to k1 times exponential of lambda t, and y2 is equal to k2 times exponential of lambda t. And then what we are going to do is just that do the first derivative of y1 and y2, and then plus y1, y2 and its derivative into our linear system. Then we would get equation 1 and 2. And then both equation 1 and 2 we have exponential of lambda t at every term in the equation. So we just divided equation 1 and 2 by exponential of lambda t. Then we would get k1 lambda equal to 5 k1 minus 3 k2, and k2 lambda is equal to 3 k1 minus k2. And then again we just move the term k1 to the k1 and k2 to the k2, and that would get equation 3 and 4. For equation 3 and 4 we can write down the characteristic equation by setting the determinant of the coefficients of k equal to 0. It is a 2 by 2 matrix, so the way to find the determinant is just that the product of 5 minus lambda times minus 1 plus lambda, and minus the terms of the product of 3 times minus 3. So from that we will get lambda squared minus 4 lambda plus 4 equal to 0. So from that we can find two values of lambda, which are what? What are the two values of lambda? What are two values of our eigenvalue? 2 and 2, which is the repeated root. So from that we are going to find the beta, but before we find beta we got to find the set of k by plug lambda into either equation 3 or equation 4. If you put lambda equal to 2 into equation 3, what do you get? See equation 3 here? If you put lambda equal to 2 there, what do you get? k1 is equal to k2. So we just plug it in, and then we get k1 equal to 2. In that case, we just assume that k1 is equal to 1. Then k2 would equal to 1 too. Okay? And then we are going to find beta by using this relationship. Okay. Write down the set of the coefficients of k times with the beta 1 and beta 2 equal to k1 and k2, and now our k1, k2 is equal to 1. From that, as you observe, you would see that either using equation 1 or equation 2 is just the same equation. So in that case, we would get beta 1 minus beta 2 is equal to 1 over 3. From that again, because we assume, I would assume as I did before, let's have beta 2 equal to 0. If beta 2 equal to 0, then beta 1 is equal to 1 over 3. Now our first set of the solution is k1, k2 is equal to 1, you just put it in, times exponential of lambda 2, lambda is equal to 2, so you you put 2 in. Now, for our second step, it's saying that for second step, C2, you get KT plus beta. K1, let me put this here. We are going to write down as this. K1 is equal to 1, right? Sorry, where is it? Sorry. K1 is equal to 1. So you would get 1 times T plus beta. What is the value of beta 1? Beta 1 is 1 over 3. So you would get T plus 1 over 3. For the second term, K2 is equal to 1. So you got 1T here, and your beta 2, we just assume that beta 2 is equal to 0. So we would get 0. So that's why we got T plus 1 over T, and down here we got only T times exponential of lambda T. Lambda is equal to 2. So now we can write down the general solution as y is equal to C1 plus C2, and you put y1 in there because we know our y1, and you put y2 in there. That's it. That's the answer of this linear system.